love the earth, it is our planet. We love the earth, it is our home.
Okay, Willem again doing a weekly training with our installers. This time we're talking about the CT, the current transformer, that most inverters or some inverters actually use to control the feed in or to measure the consumption from the grid supply. So there's also some confusion as to which cables you can use, what supply you can use, what if there's more than one cable. This is a training we'll do with our staff, and I hope you enjoy it.
CT. What does CT stand for?
Current transfer.
Current transformer. So what does this thing do? What does it do? Can't talk to me. What does it do? We install it, we use it all the time, we must know what we do. These are tools. These are our equipment. What does it do?
I think it measures the current flow.
Yes, it measures the current flow through a conductor. So let's talk about a cable quickly. If there's a current flowing through this cable, how does this thing measure the current from this cable? Because it's insulated, there's no connection. So how can it measure current if I just do that? How does that work? Do you guys remember? Yes, go Josie.
Just like a lamp on meat.
Yeah, it's like the clamp meter, exactly the same principle. How does it work? How does this thing know what the amps are running inside this cable? How does it know? If you did physics at school, whenever there's a current running in a cable, there's a magnetic field around it. It's like a magnet. So the minute there's a current comes on, there's a magnetic field around it. So if you hold the cable and your thumb shows the direction that the current flows, your fingers show the direction of the magnetic field. So this magnetic field, so the minute we put current through here, DC or AC, the minute you put current through here, there's a magnetic field around this cable. Okay? It's like a magnet. Small, but there's a magnetic field around it. So when you put the CT around the cable, this current transformer, these magnetic lines, they actually cut through the core of your CT, and that generates a small little voltage in this cable. So if there's now current flowing, let's say it's 220 watts or whatever, DC or AC running through this cable, at the end over here on this cable, whenever the end is, there is current coming out. There will be a voltage there. And then obviously one can get a current flow. So will you touch this? If this CT is around the cable, will you touch these points? Is it dangerous? How many volts do you expect to see at the end of this cable? Is it like 100 volts or less?
No.
More or less? Who says more than 100 volts? Less than 100, less than 50, less than 20, less than 10. Okay, who says more than 10?
Doesn't it depend on the type of current transformer?
Yeah, it depends on the current. Obviously, the higher the current, the higher the voltage that you'll get. All right. But what we're working with, we're talking about maybe 2 or 3 volts, if that much. So there's not much here. All right. So this cable, I think the cable that comes with the Sunsync seat, I think it's 10 meters long. Sunsync says you can extend it by another 10 meters. So you can have a 20 meter cable. If you have to go longer than that, then you have more losses and then you lose some voltage in the length of the cable. But that's the principle that this thing works on. It has a cable. Okay, so let's talk about by the way, this thing is directional because I showed you if the current goes that way and put my hand around it, my fingers show the direction of the magnetic field. Okay, this one picks up the direction of the magnetic field, and that will determine whether the black is positive or the white is positive. So if I put it this way around, maybe the black is positive. But if I change the direction and put it this way around, then maybe the white is positive. You get it? So this thing is directional. So you need to put this in the right way. We'll see it has an arrow on it. Now, some CTs, the arrow must point to the source. In other words, the arrow must point to S-block. Some of them say the arrow must point to the direction of the current flow, the positive current flow. So read the book. Or just install it, look at the inverter, look at which way the current is flowing, and you can just swap the terminals on the inverter itself. So it's not a major. So let's talk about which cable do you connect this on, all right? So with the Sunsync and all the installations we do, depending on the application, but 9 of 10 times, we want this CT to tell us if this is your main breaker in your DB, what is coming from ESCOM. We want to measure the ESCOM inputs. All right. Now let's quickly just talk about it, black and the red. So let's say we have just a positive cable that goes through here. There's a magnetic field around this cable. The current flows this way. All right. So the field is that way. If I now put the negative cable through the CT as well, the positive runs this way, so the magnetic field is this way. The negative runs that way, so the magnetic field is the other way. So they cancel each other out. So if I put the CT on, and I clamp both the plus and the minus, I'll get zero outputs from the CT because it's clamping the current going up and the current going down. Get it? Okay. So you either clamp it on either this or that. Now, if you measure AC, you take an AC cord like this computer screen. Inside that cable is both the line and the neutral. So you'll measure the current going up and the current going down, and you get no loss from your outputs. So you must always ensure that you actually capture only one cable, only the one cable talk about just now, which one. You guys okay with that? Okay. And this CT, these are split core CTs. Most CTs are actually solid CTs. The core there inside, it needs to touch, it needs to be properly closed. So when you put the CT on, yesterday I had to go fix that one site, the CT wasn't closed. The data we got from the monitor didn't work. So it needs to be, you need to hear that clip, that you know that the CT is closed. Otherwise, we're not getting usable information from the CT. Okay, right. Right. So which cable do you clip this on? There's live and there's neutral. Which one do you use? Live. Yes. Must I use the live or can I use the neutral as well? Maybe a question is, if there is, let's say there is 30 amps running in the live, how many amps are running in the neutral? 30 amps. 30 amps, you agree? Now if this is a house, is this AC or DC? AC. So which direction is the current running? Is the current running that way or that way? From this pole. But I thought it's AC. I thought it's AC. AC is like this. Yes? You agree? Yes. So sometimes it goes that way, sometimes it goes that way. So I'm saying here, which way is the current flow? Yes, through the line. Both ways. Goes up and down. Yes, you agree, because it's AC, yes? Mm-hmm. So in neutral, which way is the current flowing? Both ways, up and down, because it's AC. So you can clip the live and you can clip the neutral. People usually say clip the live because then the arrow works. Because if I clip the live, if clipping the live this way is correct, then maybe the lag is positive. If I put it around that cable, remember now the current is alternating the other way, then this is going to change. But exactly the same current that runs in this cable is the same current that runs in that cable. You agree with that? Otherwise, how does the current work? You agree with that? So you can use either live or neutral. So in the DB, there's no space on the red cable. Use the black cable. Can I use it down here? Or must I use it up there? Can I use it down here?
The one up there.
Sorry?
The one at the top.
Okay. If there's 30 amps running over there, how many amps is running over here? Remember, we just want to catch the amps. That's all that we're doing with this thing. Catching the amps. What do you say, Joseph?
It depends on that page.
It depends on
That page at the size.
the size of the break. Well, what's going to happen if this is a 10 amp breaker and you've got 30 amps running in it? What can happen in the break?
In the break.
It's going to trip. Yeah, it's going to trip, obviously. Does this break change the amps that goes through it?
No.
Does the circuit breaker change the amount of amps that goes through it?
No.
Does it filter the amps or reduce the amps? Do any changes? No, the only thing that happens inside this breaker is a switch. That switch opens and closes. That's all that the breaker does. Okay, so if the breaker is on and the switch is closed, if there's 30 amps running there, how many amps is running there? 30 amps. So can I put my CT there? Yes. Can I put my CT there? Yes.
Yes.
Can I put my CT just around one of the two cables? If there are two cables coming out of the live terminal, Can I put my CT just around one of these cables? What do you think?
Both of them.
Second,
Both of them.
both of them. I agree with you. Why?
I think the current is still the same current that is flowing on both them.
Yes, it's not the same current. So if this 30 amps running there, maybe this cable has 30 amps and that cable has 30 amps. So if I just catch the one cable, I'm not going to measure the entire current. You get it? So you can put the CT, catch both those cables, and whatever amps you measure there is the same amps you measure there. That's calculators. Or you can put the CT there. Then just know that the directions are swapped because you're measuring the in and out differently. You guys okay with that? Questions? And make sure your CT is properly closed. Okay? If it's just slightly like that, it's not going to give us the usable information. Okay. So don't be afraid of the CT. Just keep a clear mind. So wherever you find space in the deep, now maybe another question. Take us to the next one. If that is on my main switch, and that feeds my earth leakage, and my earth leakage feeds all my other breakers. But I also have a breaker over here that is not on the ticket. Let's say that is the stove. Should be under the ticket, but this one is awful. It says that is the stove. So we've got two cables coming out. The one cable goes to the stove, the other cable goes to the earth leakage. Can I put my CT around this cable? Well, I can, but should I? Should I put my CT around this cable?
I don't think so.
Why?
Leakage is always a problem of tripping and stuff, you know.
Yeah, that's an answer. But I'm talking from a current point of view. If there's 30 amps running over there, will there be 30 amps running there?
Hmm.
Why?
Split.
Because now the
Yeah.
Nice. Okay. So my reason is because the stove is before. So meaning there might be some amps on this side.
Absolutely right.
Yes.
So the other would be using 10 amps, and then the rest is 20 amps running over there. Okay. So have a clear mind. So when you decide where to put the CT, normally just above or just below your main breaker. That's where the CT normally is. All right. Guys happy? Smart. Thank you.
We love the earth.